Today, we will talk about inverse functions. Here we have a function. As we have labeled, one of the points on the graph is 2, 3. If we rearrange the coordinate by switching the x and y values, our new point would be 3, 2. If we switch the x and y values for all of the points on the graph, we would create a new function. This new function is the inverse of the original function. The range of the inverse function is the same as the domain of the original, and vice versa. In order for an inverse function to exist, the original function must be 1 to 1. In other words, it must have only one y value for every x value and one x value for every y value. The original function must also be monotonic, meaning that it is always increasing or decreasing. It can never change direction. Let's look at how to find the inverse algebraically. We'll start with a simple equation y equals x squared. To find the inverse, you just merely undo the equation by solving for x. So the inverse of y equals x squared is y equals root x. Here's another example. First, we cube both sides of the equation, then multiply both sides by 2, and finally subtract 1 from both sides. The inverse function is f to the negative 1 equals 2x cubed minus 1. There is a formula to find the derivative of an inverse function which states that if g of x is the inverse of f of x, then g prime of x equals f prime of g of x. In other words, the derivative of an inverse function g of x at a certain point is the derivative of the original function f of x evaluated at g of the point. Take this example. Say that g of x is the inverse of f of x. Let's evaluate g prime 2. That would be the derivative of f at g of 2, which is the same as f of 41 because g of 2 is 41. If g of x is the inverse of f of x, then f of x is also the inverse of g of x. So, to find f of x, take the inverse of g of x. This evaluates to f of x equals cube root x minus 1 over 5. f of 41 is thus cube root 40 over 5, or 2 times cube root 5 over 5. Let's explain the logic of this. Recall that x, y on a function f is the same as y, x on its inverse g. Say that g of x equals 5. Therefore, it makes sense that we should use the y value of g of x to find f prime, since we are using the equation 1 over f prime of g of x. It is also important to note why we do 1 over it. Let's look at it graphically. This is the function f, and here is its inverse, g. If you draw the line y equals x, you can make the observation that it serves as the line of symmetry between f and g. Recall that y equals f of x while x equals g of x. Thus, function f is set up with ordered pairs of x, y, while function g is set up with ordered pairs of y, x. Because y equals x is equivalent to x equals y, the line y equals x serves as a line of reflection between the function and its inverse. So, if you ever need to draw the inverse, just remember that it can easily be done by reflecting the original function across y equals x. And now, you're ready to solve inverses yourselves. Calculator.